Welcome to Electron. The next problem is a little bit more complicated. Here we have a function called f of t equals the cosine of omega t times e to the minus at, and we're trying to find the Laplace transform of that equation, or that function I should say. Again, the same thing. Here's the mathematical formula for the Laplace transform. And instead of f of t, we write what f of t is equal to, which in this case is the cosine of omega t times e to the minus at. Now we're going to use the following transformation. We're going to write the cosine of omega t into its exponential form. When we plug that in here, we get the following. Let's see here. This is equal to the integral e to the minus st from 0 to infinity. The cosine of omega t can now be written as e to the j omega t plus e to the minus j omega t, all divided by 2. And then we write this times e to the minus at dt. So now what we're going to do is we're going to factor out 1 over 2, and then we're going to write this as two separate integrals. So this can now be written as 1 over 2 times the first integral from 0 to infinity is going to be e to the minus s minus j omega, and bring this to minus e, so we'll bring the exponent, minus times a minus, that would be plus a times t. Now hopefully we got all the signs correct. If we apply the negative to the s, we get minus s, negative times this gives us plus j omega, and negative times a plus gives us a minus a. So that looks good. And then there will be plus a second integral from 0 to infinity of e to the minus, and that would be s. Now we'll take this one here, so that means that this needs to be plus j omega, and then plus a times t dt, and close brackets. Oh, and I need a dt over here as well. All right, now let's see if this is correct again. When we apply negative times s, we get a negative s. A negative times j omega, we get a negative j omega, and a negative times a, we get a negative a. So this looks good. We have two good integrals, and we have the 1/2 factored out. So let's go and integrate this. This becomes the following. This is equal to 1/2 times negative 1 over s minus, I'm going to write as s plus a minus j omega, and you'll see later why we rearrange the terms here, times, this will be e to the minus quantity s plus a minus j omega times t, evaluated from 0 to infinity. Then we get minus 1 over s plus a plus j omega times e to the minus s plus j omega plus a times t, evaluated from 0 to infinity. Close brackets. All right, so what we've done is, well, of course, we end up with these two denominators because we need the proper differentials. Make sure we have that correct. S plus a minus j omega, s plus a plus j omega looks good. We have the minus 1 because this minus right here, and the minus because this minus right there. Very good. Evaluating these two now, what do we get? If we plug in infinity, we get minus infinity, e to the minus infinity, that is 0. Plug in a 0, we get 1. So this can now be simplified to 1/2 times a minus 1 over s plus a. I'm going to group these together, minus j omega, and that would be times, that would be 0 minus 1, minus 1 over s plus a plus j omega. And plug in the upper limit, we get 0. Plug in the lower limit, we get 1. So that would be also 0 minus 1. You notice in each case, we're multiplying times a minus 1. So the minus and this minus will become plus. This minus and this minus will become plus. So when we simplify that, we get this is equal to 1/2 times 1 over s plus a minus j omega plus 1 over s plus a plus j omega. Now we need to add those two fractions, which means we need common denominators. The common denominator will simply be the product of those two. So let's see, maybe I'll move up to the right side of the board. I'll have a little bit more room there. So let's move up here. So this is equal to 1/2 times, that'll be s plus a plus j omega plus s plus a minus j omega in the numerator divided by the product of these two, that will be the common denominator, s plus a plus j omega multiplied times s plus a minus j omega. Now you can see in the numerator, the j omega will cancel out. That's a plus, that's a minus, so they'll cancel out. We have an s plus a, that gives us 1/2 times 2 times s plus a. And in the denominator, it'll be the product. We have a plus here, a minus there, so the middle term will disappear. So end up with the quantity s plus a squared. This times this is a minus j squared omega squared. And of course, j squared, j is the square root of -1, so j squared is -1. So this times this becomes positive, and these cancel right here. So we end up with s plus a in the numerator divided by s plus a squared, and it'll be plus omega squared. And this here is the Laplace transform then of our original equation right here. F of t equals the cosine of omega t, e to the minus at. The Laplace transform of that will be found right here. F of s is equal to that. And that's how we find that.